Hello, I'm John Pitchford. I'm a mathematical ecologist at the University of York, and I'm representing our large, exciting consortium about pyramids of life. Thanks to the funders, the audience, the organizers, and thank you especially to the partners who helped us to put together this really exciting piece of work. I'm going to try and sell you the big picture of what we're aiming for within this project, and then I'm going to show you how we're mapping that big picture onto a few realistic, concrete challenges. And then I'm going to be appealing for your help as a wider audience because there are some things where we do need assistance. Right. So here's the big picture. It's a smart motorway. At times of high traffic flow, it's been shown that the best way to organize a motorway is to open up the hard shoulder and to equalize the flow of traffic in each lane. So nobody's changing lanes and nobody's causing these horrible tailbacks that mathematically they're called instabilities. And they're what result in you being stuck for 3 hours on the M1. You can see you also have to have cameras monitoring the traffic and you have to have escape lanes. So if that's what a smart motorway does, maybe we can take that analogy and apply it to a size-structured marine ecosystem. And this idea of equalizing flow will be about trying to exploit equally all of the size categories in our ecosystem. Exploiting the hard shoulder, well, that might be about trying to find new resources that we weren't previously harvesting and use those in a responsible way. We know that smart motorways are dangerous without monitoring and safety, and in the same way, this balanced harvest idea I'm trying to sell you is not a panacea, and we need the involvement of managers and governments to make it work. So the big picture is that we know the maths of how an ecosystem is structured. We know why. There are lots of small things, a medium number of medium things, and a small number of big things, a natural ecological pyramid of numbers. The problem is a mismatch. You can see in these figures here, where what the consumers want is lots of big things and maybe a few medium things, and nobody wants the little stuff. And that corresponds with what the fishers are able to catch, partly because of consumer demand, another inverted pyramid. And you can imagine mathematically, we've got a mismatch between a natural emergent ecological pyramid and the human imposed inverted pyramid that causes instabilities and can crash fisheries. So if we can work with the industry, with the consumers to better align demand to a natural, stable ecological ecosystem, that will help us to do things more sustainably. There's a word for this, and it's very controversial in the literature. It's called balanced harvest. Some people sell it as a religion or as a panacea. It's not, but it certainly could be a way to better align what we catch with what society needs and with what the ecology can sustain. So there are lots of papers about this. There's also some brilliant software which takes this abstract mathematical idea of size spectra and turns it into real data-driven species-level science. Right, what's the reality of this? Well, thanks to COVID, we were able to work with our project partners really constructively and enjoyably, and we've used them to drive where we're going through in this project. So the first work package was co-developed with Seafish, the industry body, and they've identified gaps within what their partners in Southwest England are saying, that they think there are species there which we're underexploiting and which we can do better. And which they're unable to within the current regulatory framework. The second work package was generated through Waitrose, and they're a supermarket that's committed to sustainability in everything that they do. And they have some track record here. They've been promoting a thing called forgotten cuts in the past, which is trying to get the consumers to use different pieces of meat that they weren't previously using. If we can work with them to find out where there are these gaps in the marine system, which align with ecological theory, then that's a win for both sides. And the third work package is to try to extend these ideas more broadly. And again, we have excellent partners on board with that. So I thought, as a mathematician, all I would have to do is show you my partial differential equations and everybody would agree and they would change policy immediately. It turns out it's not like that. And that's where I've learned so much from working with excellent colleagues at UEA and CFAS. We can't do this with mathematics. It's got to be about people. So we need to measure human needs and perceptions. We need to align those needs and perceptions to what the ocean can actually provide for people. We've got the tools in place, but we're still developing those for more complex ecologies. And then we need to translate those outcomes into things that people can use. Finally, what do I worry about? We've got beautiful theory, we've got fantastic data, we've got really talented people within their field, and we work together really well. But what we can't do yet is to know how to translate those ideas into things which are acceptable for consumers and the industry, and which managers can turn into something practical, and which the regulators and the governments can agree to and they can see the legality of. So that is where I think I'll be appealing to this wider community for assistance as the project goes on. Thank you very much.